This is Twit.
Bandwidth for Know-How is brought to you by CashFly.
This episode of Know-How is brought to you by the Ring Video Doorbell. With Ring, you can see and talk to anyone at your door from anywhere in the world using your smartphone. It's like caller ID for your home. Right now, get free expedited FedEx shipping when you go to ring.com/knowhow. And by DigitalOcean. Simple and fast cloud hosting built for developers. Deploy an SSD cloud server in 55 seconds. Try it today for free. Visit DigitalOcean.com, and once you sign up, be sure to enter the promo code KNOWHOW in the billing section to get your free $10 credit. On today's show,
Know how not to crash into your garage.
welcome to Know-How. It's the Twitch show where we build, bend, break, and upgrade. I'm Father Robert Ballecer.
I'm Bryan Burnett.
And for the next, we're trying to get it down to 45 minutes. We're going to be showing you some of the projects that we've been geeking out to so you can take them home and geek out on your own.
Yes, and it seems like it's been a while since we last geeked out.
In release time, no, because we had the whole pre-recording time machine going on. But I was on vacation and then I was covering CES and you were gone as well. So it's actually been close to a month since the last time we've done this show.
Right. So
which yeah, I'm sorry if we just broke the magic.
Yeah, that's why things are going so smoothly right now.
Yeah, exactly. Now, you will notice we are continuing to change the format. Remember, we've gone to a 2-show-a-week format. The Thursdays are going to be reserved for sort of the heavier builds, a bit geekier.
Right.
We're going to try to do Mondays, which is actually pre-recorded on Thursday, to be sort of the know-how light. It's lighter topics. People who maybe don't want to pick up a soldering iron or play around with an Arduino.
And we'll have know-how classic.
Know-how classic. And
know-how classic.
After a while, people were like, no, I don't like this new light stuff. Bring back classic, and then we'll have 3 shows.
It's all about branding.
Maybe Know-How Zero.
Oh God, yeah.
Know-How Clear. Actually, yes, Know-How Clear.
Wait, no, was it not Diamond? Wait, Pepsi Clear?
Pepsi,
was that what
yeah,
it was?
It was Pepsi Clear. Yeah. All right, but before we jump into the main topic, there is a holdover question that we want to use at the top of the show from people who liked the Arduino project. They especially liked the Christmas lights, the Arduino Christmas lights, but there was some confusion as to how to wire it. I thought we should probably spend the top of the show talking a little bit about some of the parts that are out there that you can get, and then do a quick tutorial on how you actually put it together.
Cool, because yeah, that was one of my favorite projects that we did, because anything with blinky lights, I'm all up for. So show us how to wire this.
Let's do some blinky lights. Okay, so this is the setup that I brought with me to Hawaii. This was our Christmas light setup. So this was attached to our balcony, which the hotel staff told us we were not supposed to have, because you're not supposed to hang things off the side of a hotel. Oh. But then but it's so Christmassy, so go ahead and leave them.
But it's awesome, so
it's
don't
awesome.
worry. Yeah.
So this is what it looked like. It was powered by a single 1,000 milliamp 3S battery.
Which will charge it for a while, right?
We'll actually run this for like 20 hours.
Yeah, that's pretty cool.
I mean, there's no trouble whatsoever. I put it into this waterproof case, so I made it water resistant because it does rain a lot in Hawaii.
Makes sense.
And these are already water resistant. So this was pretty much a watertight package. I wouldn't take it underwater.
Yeah, but
it was
good enough
just fine
for holding it outside. Yeah.
Exactly, for a balcony. So this is what a typical setup will look like. This is a strand of, these are not WS2812s, which is what we've been using. These are WS2811s. A bit more robust, use up a tiny bit more power, but they're perfect for Christmas lights.
Yeah, they're really pretty.
Exactly. Now this is an Arduino that's running some software that I actually wrote. It just takes it through some of the fast LED display modes.
Right. So is this the code that you went over that one episode that you kind of modified?
Precisely. Now, if you look inside here, this is actually really, go to the overhead. This is a super simple circuit. So let me show you the things you don't need. This is just a battery eliminator circuit. It takes whatever voltage I give it. I can give it between 7.4 volts and all the way up to 18 volts, and it will convert it down to 5. Which is what I need for both my lights and the Arduino.
Right.
And then this is a filter circuit, because I did not want the Arduino and the lights on the same circuit, because what will happen is this will actually draw, the strand will draw differing amounts of power depending on what colors are being displayed.
Right.
I didn't want that voltage fluctuation to be pushed into the Arduino.
And that could either reboot the Arduino or even break it?
Or even, yeah, you could kill it. I mean, if you give it dirty enough power, it will kill it. So what the filter did was, it takes the power from the battery eliminator circuit and then breaks it off into two pieces. So the pre-filter goes to the lights, post-filter goes to the Arduino.
Yeah, then you don't have any conflict.
Right, no conflict. It's still running off of the same power source, but it keeps it a little cleaner. By the way, I know we're not supposed to mention quadcopters.
Quad what?
Quad multi-rotors.
Yes.
But this is actually the way that you would clean the power going into your FPV system. If you didn't want all the interference, the EMI, from the motors making its way into your transmitter, you would put one of these circuits.
Because as you give the motors more throttle or decreased throttle, it's drawing different amounts of power, and that would mess it up?
Well, we've all seen that. When you run an electric motor, you start to hear static.
Yeah.
That's EMI. That's electromagnetic interference.
Okay.
This is a good way to filter out. Okay.
Cool.
But let's look at the circuit itself. Super, super simple, folks. So this right here, this is red and black. These are going to the VIN, and ground. This is what actually powers my Arduino. I could power it off of the USB port, but instead I've got 5 volts going in right here.
Right.
Okay. Now, I need to provide power not just to the Arduino, but also to my strand, and then I need to connect it digitally to this board, because this board
is
these
sending the
pins
signal.
over here, precisely. So I need 2 things. I need power for this, and I need digital connection and a ground on the Arduino.
Right.
Okay, so this is what happens. This little strand right here, you'll notice there's actually 4 wires. This is power, so this is providing it power. This is just 5 volts straight to the strand. This is ground and the digital lead.
Right, so there's 2 separate connections. Okay.
There's 2 separate. Well, see, this is what freaks people out. The ground is actually the same. So the ground providing the power to the strand, and the ground providing the other side of the digital lead, it's the same. It's the same ground. I just haven't split off for ease of connection.
That makes sense.
Okay.
Why would you want to do multiple grounds?
Well, because you need one ground that's used to provide power for the strand, and if you don't have a ground, like let me remove the ground pin. If I remove the ground, this is just going to keep doing what it already had in memory. The strand is never going to receive another proper command from the Arduino.
So it doesn't refresh?
It doesn't refresh. So it's just doing what I told it to do, but it's not going to receive new commands. Get back in there. There we go, 13. See, that's what it should have been doing. So what I'm going to do is I have ground going to the strand, and then from the strand ground to ground here.
Back to the board.
And to digital pin 13.
Oh, okay, cool. So
yeah.
that completes the circuit.
That completes the circuit. So I know this is sort of confusing to people who are not at this level, so let's break it down even further.
Sure.
Let's go away from my Christmas lights, and let's go to a standard prototype kit that we've got from the Arduino, so we can see exactly how it works. So we've got a bare Arduino right here.
Okay.
So this is an Arduino. This is a breadboard.
On a 3D printed little
on a 3D printed little slidey thing.
Yeah.
So what we're going to do is we need a way to bring power to here so that I can power any objects. Like, for example, let's say I want to power this strand of lights. Actually, let's use this one. Boop.
Ah!
Yeah.
Jeez.
The strand of lights.
Easy there.
So what I'm going to do is I'm going to use jumpers. Now these are really simple. I bought a ton of these. In fact, there's going to be a bunch of these down in the no hole, and they typically look like this, which is to say a mess.
Yeah.
These are all the jumpers I
But
have.
great for breadboards.
Great for breadboards. So I want a red one and a black one if I can find one. I can't.
Well, there's a red and a black one already attached. Oh,
Yeah,
no, there's
see,
3 attached.
So I messed up. So I'm going to bring it down. So from ground. This is, see, I wish the camera could get in tighter here. There, Alex, can you zoom in on that one? See, that says G and D, that's ground. VIN, that's voltage in. Now, voltage in and 5 volt are both the positive side, so I could take from either of those.
Okay.
In this case, I'm going to take from 5 volt,
So
and I'm going to take the ground. Oop,
Okay.
Let's actually switch that.
This is taking the power that's going into the Arduino and putting it out into the breadboard.
Putting it out so I can power something else. So let's see if I can get a better angle there. What you can see is I am actually taking 5 volts and ground, and then I'm going to put it into this breadboard right here. So on this side, I've got ground, and on this side, I've got 5 volts.
Now, how do you know where to put it on the breadboard?
Anything. So the way breadboards work is that entire row are all connected.
Oh, okay.
So now anything I plug in here or here is going to get 5-volt ground, 5 volts.
Ah, okay.
Okay. Now, if I give this an internal, if I give this voltage, so I'm going to plug this into my computer. So I've got 5-volt power going in through the USB port. This is now taking that 5 volts and it's pushing it back out here.
Into the board.
Into the board, which means I can now take something like, where did that go? Didn't I?
Oh,
the
right
thing I
here?
just pulled out.
Yeah.
This is a standard pixel string, so it needs ground, it needs 5 volts, and then it needs a digital pin. I can now take this is the positive side, I can plug it into the positive side there. I can take this, plug that into the negative side there. And now this is my digital pin, and I could plug this in, say, digital pin 7, 3, whatever it's going to be. It won't light up because I have no logic in there right now.
Right, that's just what you use to send a signal to control the lights.
Correct, correct. So this is a complete circuit. Right now, if I were to send the same programming here that I had on that other board, this would start to light up.
Okay.
Yeah, but that's all it is. So I am taking the same voltage off of the Arduino that I'm giving it through the USB port.
Right.
It's really not more complicated than that, folks. Now, I will say this. For something like that strand,
Right.
that needed more power than I could get from just the Arduino. I would pull way more power through that board than it was designed to
And
handle.
variable amounts of power, right?
And variable amounts of power, which is why I gave it its own power supply. And you can totally do that. So if you have something like, say, a servo motor that needs digital logic, but at the same time cannot be driven by the power that the Arduino can supply, give it its own 5-volt, and then just give ground and the ground and the data line, the digital line, back to the Arduino, and you'll be good to go.
Cool, that makes sense. Yeah, the breadboard, the only difference between this breadboard example and your Christmas lights, isn't it just that the breadboard's kind of like the middleman at this point?
Right. There is no reason to use a breadboard. In fact, if you remember the other version I had, there is no breadboard in there.
Yeah.
You can wire directly to the Arduino. In fact, most of my projects are. But I like the breadboard because it allows me to mess around. So I can very quickly move from connection to connection without soldering and desoldering or cutting or anything.
Right.
And it also means that I can sort of, once I'm done, I can picture what I've created and then make it neater.
Yeah. Yeah, exactly. It's a great way to test.
It is a really good way to test.
Cool.
Okay, so that's some of the basics. Let's go ahead and run into the problem, because you know, one of the things we like to talk about is this whole, what's the process of invention?
Right.
And I have a problem.
What's the problem?
My parents keep running into the garage door wall.
And why does that keep happening?
It keeps happening because they changed their car. So for the longest time, they had been driving a
Toyota Sienna?
No, they had a Lexus.
Oh, okay.
And it's a long car. And now they're driving two Prii, which is a short car. So they think, well, I need to drive in further than I did before. And the depth perception, not so great at that age anymore.
Aw.
And so like,
Okay.
I just visited them in Las Vegas for CES, and
Yeah.
we have cabinets, and the
Right.
bottom row of cabinets are all broken.
Oh,
'Cause
wow.
the cars actually punch through them. It's like, oh.
Jeez.
You know, like, Dad, okay, how about this? When you hear the crunching, stop.
Well, you can never really be sure until you hear the second crunch.
I just think, wait, was that a crunch, or was that just something on the ground?
Yeah, exactly.
Keep going. Oh, no, that was a crunch.
So you're trying to come up with a way to signal them to stop from continuing forward.
I want a cheap way, not just to signal them when to stop, but also to sort of give them a warning, because
Right.
I want them to sort of learn. They have to learn what it actually looks like.
Right.
So it can't just be go or stop. It has to be, hey, you're getting closer, you're getting closer. Okay, no, really, stop. No, dude, for reals.
So, I mean, I have seen people who put a tennis ball attached to a
Yes.
string in a garage to gauge the distance, but this sounds like you want to do it with the Arduino.
Believe it or not,
Which would be a lot cooler.
This will be cheaper than a tennis ball. I mean, people are like, oh, well, why would I do that? Why don't I just go into those stopper strips they have that you put them on the ground and then like your wheel rolls over it and tells you to stop.
Whatever.
Yeah, but those are going to cost you $20. Even a tennis ball, a decent, well, unless you
Well, you have to
steal a
buy them
tennis
in like
ball.
a 4-pack. or
Yeah,
something,
you know, $10 for a tennis ball. What if I were to tell you that I can make a device that does much better than that,
Yeah.
but make the whole thing for like $5.
And cooler, because
you made it.
The way you're going, I'm imagining, like, you know, when on an aircraft carrier, a jet's coming in, and they're like, you're on the ball, and you have the lights, and they're showing like you're too close, you're too low, you're too high, you need to like level out. Like something like that, where it gives you a yellow colored LED or something if you're getting just close enough, and then red if you've gone too far.
Exactly. So that's precisely what we're going to be doing. We're going to be giving them the meatball.
The meatball?
And they can call the ball when they get in the garage, and it's time for them to park. But okay, so if you go ahead and go to the first part, this is the first piece, Alex, the eBay link. You need an Arduino. That's a video, but it's a very good video, but we want the link first.
We'll save that. That's a tease.
We are going to need an Arduino. Now, we've got a couple of different Arduino types here. This is one off of eBay. This is $346. I bought these for as little as $2.
It may not be an official Arduino, though.
No, it's like, this is Sarduino.
Sarduino. It comes in a little can.
Yeah, with fish.
Yeah.
But like, all of the Arduinos in this box right here, I think there was like a grand total of $20. There's like 20 of them here. And everything from, I like these. These are like the little nanos. So we'll be playing with these later on. To this is sort of one that's been set up for more extensive breadboarding. It's got its own set of connectors and headers on the actual board. But you don't need any of those. Get the cheapest one you can possibly find. You can find one for less than $2, and you'll have yourself something that's compatible with an Arduino Uno. Just remember, you need an Atmel chipset. It's an Atmega, probably a 368.
Okay.
The second piece is this. Alex, if you go to the overhead, this is an HC SR04 ultrasonic sensor. These are about 99 cents.
Wow.
I bought 10 of them for under $10. So there we go.
Well, I remember you wanted to do a collision avoidance system for your drone using these little guys.
Precisely. And we can still do that, but this is going to be the same properties. But the nice thing about this is it's on all the time. There's no swinging tennis ball. There's nothing on the floor. But it's very accurate as far as big objects are concerned when they start approaching.
Like a Prius.
Like a Prius.
Yeah.
That's about to hit the cabinet.
You should have a sign that comes up and says, danger crunch zone near.
Crunch zone. And the last piece is this. It's a pixel stick. Alex, go ahead and show them this. This is from Ready to Fly Quads. I trust Ready to Fly Quads. I like them because they have these little connectors on the edge that allow me to daisy chain them. If you were to go on eBay, you could find these for about 99 cents. They're not as good, they're not as high quality, but then again, this is just going to be sitting in the garage.
Yeah, okay.
Right. Now, you can make this as big or as small as you want. You can do just 8. You could link together a bunch of these and have like a multiple strips.
You could probably even take your Christmas lights and use those.
Exactly.
Yeah.
If it does WS2811 or 2812 signaling, it will work just fine. So basically, any device that we're going to show you a bunch of these, that can speak this protocol, you can use. Find the one that you like.
Cool.
Okay, so let's start with the basics. We've got ourselves a device here. This is an Arduino. This is a Sarduino that we put in this 3D printed enclosure. I'm actually going to give you the files to make this because it's a 3D item that we made on Tinkercad.
He's so cute.
I know, it's like
a little
Wally.
face. Yeah, a little Wally.
And this is how it works. The the SR04 has 4 pins. There's 4 pins here, and they're actually labeled. You probably can't read that. Actually, hey, Alex, can you get in on the?
Hey, Al.
There. Hey. There we go. So we've got VCC, trigger, echo, and ground. So VCC and ground are power, 5-volt power.
Makes sense.
Okay, so give it ground, give it positive. Trig and echo, this is how the sensor works. When I send a signal to the trigger, it's going to send out a pulse,
right?
An ultrasonic pulse. When that comes back, so when it hits the object and then comes back,
that's the echo.
It sets off the echo.
That's like how bats use
echolocation.
Echolocation, yeah.
And then it's simple math. I know the speed of sound. I know that if something has gone out to something and then come back to me,
that's how far away it is. Yeah.
I find out what's that distance divided by 2, because it's a return trip.
Right.
So that's exactly what's going to happen. We don't actually have to do that math because I found a library on the internet that someone did the math for us.
And that's the beauty of libraries.
That's the beauty of libraries. Yeah. But that's how this works. So this is just sending out signals, and it's waiting for the echo.
Okay.
And as it gets closer and closer, that distance gets smaller and smaller and smaller.
Right.
So we just need to interpret what that means.
And you're gonna, at this distance, it's gonna change the LEDs. At this distance, it's gonna change the color of LEDs, right?
Precisely. Okay, so take a look at this, and I'll show you how this is wired in. we've got the 4. So the ones on the outside, this green one and this gray one, that's power. So just like I showed you in the example previous, I'm taking power directly from the Arduino. So the gray is going into ground, and the green is going into the 5-volt power. So this is getting 5-volt power from my Arduino. Okay. On this side, I've got 2 pins. Remember, I need a pin for the trigger and a pin for the echo.
Right.
Because one has to tell it when to pulse, and one has to be listening for the pulse to return.
Right.
So I've got one plugged in to digital pin, what is that? 13, and one plugged into digital pin 12.
Cool.
Now, there's just the coding. So this is the simplest version of an ultrasonic ranger I can have. Let's go ahead and plug it into my
And the
laptop.
Ranger's not pulling enough power that you need to do the separate 5-volt circuit like we do with the lights.
I can do this plus a bunch of lights, and it's still not going to tax the internal power supply of an Arduino.
Cool.
All right, so what we need to do is we need to first load up the library that we're going to be using. And again, we've got this is all encapsulated inside of a zip file, so don't feel the need to search the internet. Just download from the link on our show notes, and you'll be able to get the library. You put that library, let me show you really quickly. This is actually important because some people were freaking out over this. Find the library folder of wherever you're keeping your Arduino software. So this is called, oddly enough, libraries. And all I have to do, if you can zoom in on that a little bit, Alex. Actually, I can increase the sides from here. All you have to do is copy the folder over with the library into this library folder, and now you'll be able to use it inside your IDE, your integrated developer environment.
Cool.
All right? So let's go ahead and jump back in. Here we go. We need to first tell it that we're going to be using the ultrasonic.h library. So that's an include, INCLUDE. And notice how it changes color, so it knows something's about to happen. It knows that I'm about to include something. And then in quotations, ultrasonic.h. Okay. Now this means I now have access to all of the functions that are in the ultrasonic library, the ones I did not write. That's where all the math is concerned.
Cool.
Okay? All right, so now let's go ahead and we need to tell it where are those pins. Remember I said it needs 2 pins, right?
Right, so that you send out the signal and receive the echo.
Correct. So I need to tell it here where are those pins located. I'm going to go ultrasonic, which is a function. And notice how it changes color. So it knows it's a function inside the library. So it's recognizing it. Ultrasonic, my library, ultrasonic 1312. And then close it off. So what this is telling it is call the ultrasonic library, call the function ultrasonic, and pass it the numbers 13 and 12. And what I just told it was my trigger pin is on 13, my echo pin is on 12.
Got it. Okay. So that's the order that it's going to be in. So instead of doing 12, 13, you'd have it in reverse. Would it work?
Well, I mean, if you did it the other way, it wouldn't work, but then you would just switch it back. You wouldn't destroy it. You
wouldn't get a signal.
It wouldn't work, exactly. All right, now in the setup, I need, right now, it's going to be listening, but I need a way to see what it's actually doing. Okay. So I'm going to push that data out to the serial port so I can watch the output on my laptop.
Okay.
And you'll remember this if you watch the episode we did on Christmas lights. It's a serial command. So I'm going to, if you go back to my screen, Alex, serial. Notice how it changes color. Dot begin. So I'm opening it up. 9600. I'm setting it for 9600 bits per second. 9600 baud.
Now, how do you know the range? Did you test this out before?
I tested it before.
Okay.
Yeah. And think of that as I'm turning on that modem and getting that wonderful sound.
Yeah.
And only the old people in the audience know what I'm talking about. Everyone else, we don't care about you. All right. So. This is something that we talked about on Coding 101. This is something that we talked about with Smitty, which is you want as little as possible in the main body of the program.
Right.
You want most of it done outside because you want to keep it simple. So if you go to my laptop, Alex, this is the main program loop. So this is the one that once I start up the Arduino, it's going to do it over and over and over again.
Right.
Actually, you know what? Let me see if I could increase my my font size here because there's going to be people at home who are not being able to see this.
Yeah, those old people who knew what that sound was also won't be able to read this.
Again, now you can see it. All right, so what I want is serial. So I'm calling the serial function again. Print line X. Delay 200.
That's 200 milliseconds, I'm guessing?
Mm-hmm.
Cool.
Oh, sorry, no, wait. I skipped a step. I want this. I need a separate function. So I'm going to put void. So I'm creating a function called range debug int x. So I'm creating an integer x.
Right.
And now I'm going to call all that stuff I did.
Oh, okay.
I actually broke my own rule. I was about to put this in the main program loop. I don't want that in there.
Oh, Padre.
You know.
Just to show you how tricky programming can be.
Well, this will be easy. Again, this code is going to be available on our show notes. So what this is going to do is when I call the function called range debug, I'm going to pass it a number, and whatever number I pass, it's going to print to the serial console, which will show up on my laptop.
Cool.
Okay. Now let's go ahead and do our main loop, and our main loop is going to look like this: int range equals ultrasonic dot ranging, and that should change colors.
Cool.
CM. What I just told it is I want you to create an integer variable called range, and into that variable I want you to put the value you get from the ultrasonic library, the ranging function, in centimeters. So how many centimeters away is it?
Okay.
Okay. So that's what's going to end up inside that range variable.
Cool.
And then what I'm going to do is this: range debug range. And what that just did is it calls the range debug function, which I created here, and it's passing it the number that I just created, the variable range.
Right.
And I'll delay this by 100 as well.
Okay. Are there other units of measure that you can use, or do you have to
yeah,
go to the
but
library to
centimeters
find
is the best one to use
That
in this
makes
library.
sense, yeah.
Okay, so let's sketch it really quickly. Let's find out if I made any mistakes. I probably did, because I always do. And what it's doing is it's going through all of my code.
Oh, no,
there we go.
Right?
It's done. So I'm going to go ahead and upload that.
Cool.
And what I need to do is I need to tell it where I am. I think I'm on COM port 6, and I am using an Arduino Uno. Oh, it's Arduino Uno.
It's Arduino. That may not be on the list.
And now we're uploading. So it's going to compile. It's going to upload.
And so you hit the debug button on the.
Right.
On
It's
the
just it's like a
Arduino.
reset basically.
Yeah, reset.
It makes it ready to. Okay, now it's done uploading. Okay, so now if I open up my serial monitor, what you should start to see is numbers.
Oh, ho, ho, ho.
So this is telling me how far away an object is from the ultrasonic sensor.
In centimeters.
Yeah. For example,
That's cool.
let's go ahead. Hey, get away from that. So let's say my dad is driving this TIE fighter. Come out to the large shot. Now go back. As it gets closer and closer to the ultrasonic sensor, I notice that the range is decreasing and decreasing and decreasing and decreasing.
Too close.
Now, see, there is something funny that happens right at the end here. So if he hits the sensor, you'll notice the range goes crazy.
Because it's bouncing right back.
Because it's no longer bouncing.
Oh, because it's
I'm
blocking
covering.
the
I'm actually
signal.
covering the signal.
Ah, okay.
So at some point, when we make this more advanced, we need to add in like a screen. You have crashed. You have just hit the sensor.
If you see a value over 3,000, then you have crashed.
Exactly. Okay, so this is good. We know that the sensor's working, and we know that we can now use that. Now you're trying to fool it.
Well, now I'm
now you're just messing with it. So we know how this works, and we know how simple it is to get this up and running. But what we want to do is we want to make this in some sort of useful format, because obviously my dad's not going to have a laptop open
just showing him
with a
numbers.
USB cable connected to the thing. He's like, let me connect this and then drive in.
That would be very elaborate. Like someone has to run out with a USB cable before he comes into the garage.
Dad, let me hook you up. Yeah, so we need to create some sort of feedback device so that he can see at a glance how close he is.
And that's what the LEDs are going to be for.
Well, maybe.
Oh, maybe. I mean, whatever.
Thanks, bro.
I don't know. Does this spoil?
Yeah. All right, now we are going to show you how we're going to do that, and we're actually going to show you how we created a 3D enclosure for this. But before we do that, you know what I want to do?
What's that?
I want to thank the first sponsor of this episode of Know How.
Yeah. Speaking of your parents, they
Speaking
also
of my parents,
have one of these.
Yes, they do. The Ring video doorbell. Now, they were at CES this year, as they have been for the last couple of years, and they have something that I really like. I'm not supposed to talk about it, but I'm going to talk about it anyways because I liked it so much.
I like that you preface with that.
It's the stick cam. So think of it as it's the Ring video doorbell, but without the doorbell. So if people have been wanting to put multiple Ring video doorbells everywhere.
Right.
Now you can just buy the unit that does the motion detection and the two-way conversation.
Oh,
and
without the actual button on it?
Without the actual button.
Oh, okay.
But that's not what we're talking about. We're talking about the classic. This is the Ring video doorbell. Folks, this is the device that Time Magazine called one of the best gadgets. Now, you got to check this out. Here's what's inside the box. Inside the box, you get everything you need to install it. That includes, let's see if it's powered up. Of course.
It'll be powered up for a year now.
Yeah, the Ring video doorbell includes all the tools you need, from the drill to the bits to even a level to make sure you install it properly. Now, if you've ever installed a doorbell, this is really no different. You have the 2 wires that come from your house that plug into the terminals here, and it provides power to the Ring video doorbell. So when someone pushes the button, you get a ring on the inside. Now, that's okay.
Right.
But what makes it cool is what happens after that ring is depressed. It will show up on your mobile device, be it your tablet or your phone, and it allows you to have a two-way conversation with whoever is at the door.
Yeah, that's cool.
I love this. This is really, really cool. Now, one of the very cool things about this is that it also does motion detection. So you can set a perimeter. You can say, look, if someone comes within 60 feet of my door, I want you to start taking video.
Right.
And it will push it up to the cloud.
And then you can find where the package went that the UPS guy threw over the fence.
I was talking to the folks over at Ring, and I was telling them, look, I'll give you my videos. I recorded 2 videos. One of our neighbor stealing our power. He was coming into our courtyard.
Yeah.
He's plugging in an extension cord so that he could run his air conditioner off of our power.
Yeah, and then you can yell at him through the...
Hey, what are you doing?
Yeah.
And also, we caught a truck that was taking a package that had just been delivered across the street.
That infuriates me.
But yeah, we got him on camera. The Ring video doorbell isn't just about comfort. It's not just about good gadgetry. It is a device or peace of mind. I bought it for my parents before Ring was a sponsor on the network because I was worried about them. I wanted to be able to keep tabs on them. My phone is connected to their Ring video doorbell, so I can see who comes and goes. And when they go on vacation, this is the best part. When I know that they're gone and I'm detecting motion in the front yard,
a little suspicious.
A little suspicious. I check it out. I always check it out. Try it. Seriously, try it. See if it doesn't give you a peace of mind. See if it's not one of the coolest gadgets that you get in your smart home. This is the Ring video doorbell, and you know what? They want to make sure that you can get it right now. Because you are listeners of Twit, because you are loyal followers of Know How, Ring is going to give you their advanced motion detection. They're going to help you stop 95% of break-ins. They're going to let you install this in minutes and have your house up and running with the latest and greatest in gadgets. Just put your mind at ease and go with the Ring video doorbell at ring.com/knowhow. Again, that's the video doorbell that Time Magazine and USA Today named as one of their top gadgets of 2015. Go to ring.com/knowhow. Ring.com/knowhow for free expedited FedEx shipping. Again, that's ring.com/knowhow. With Ring, you're always home. And we thank Ring for their support of Know How.
Thanks, Ring.
Thank you, Ring. Hey, Brian.
What's up?
You know what I like?
Arduinos?
I like
Arduinos.
I like
on your
Arduinos.
pizza?
I also like a little bit of 3D design.
Yeah, well, you've got a couple of little 3D printed things out here on the table.
We got a little something. These are all super simple. But what I wanted to do was I wanted to give our audience a way for them to make their own custom templates. I created these for Know How because I had a very specific demo in mind.
Right.
But I want to make it easy for our audience to take what we've done with this and maybe make a design of their own.
Cool.
Now, let me show you really quickly. If you go to my computer, Alex, so these are, again, this is Tinkercad. It's a free service on the internet, www.tinkercad.com, and it gives you a pretty full-featured 3D design tool. Now, what I like about this is Tinkercad is from the makers of AutoCAD. So you know that they know what they're doing. And unfortunately, I must be on an incredibly slow internet connection right now.
So I was using Office earlier and it wasn't working. I had to switch to Guest.
Yeah, let me... who's on production? Get off. There we go. Okay, so come on back. So this is what do you call it? This is the actual carrier. So I needed to create a carrier for an Arduino, and that's what this does. This allows me to safely snug an Arduino into a housing. This is bare bones. Well, what it allows me to do is it allows me to take this object and then do anything with it. So do I want to make a wall mount? I can do that. I just add the supports around it for wall mounting. Do I want to make it something that connects to the bottom of a car? I can do that. I can just put the supports to hook it up to, say, a support bolt on the bottom of the car.
Right.
In fact, the Christmas light enclosure that I made, this is a custom version of that Arduino carrier that I designed to fit the contours of the inside of the Otter case.
Yeah.
So it's nice to have this. I like having a library of simple objects that I can customize just a little bit to make it fit wherever I need it to fit.
That's the perfect reason to have a 3D printer.
It's the perfect reason to have a 3D printer, and with Tinkercad, it also gives me the ability to do it with everything else. Let's see. Yeah, here we go. This is the HCSR04. So again, this was the template for. This is the template for the object I made to hold that ultrasonic sensor. So I can combine this with the Arduino holder or with anything else to give me a mounting point, an easy mounting point for my sensor.
You could put even a little face on it. You put a little smiley face in there or something.
Now, Alex, if you go ahead and go to the video, once you've got your object, once you've put it together, go ahead and run it through your 3D printer. Again, this is the Dremel, the idea maker that we've got now in my lab, which is fantastic.
Yeah, the resolution on the prints is awesome.
I'm really, really liking this thing. And this is probably the best way for you to use your 3D printer. You don't have to design everything from the ground up. It's much like using a library in Arduino. Use something that someone else has already made, but then just tailor it for what you need. What is your specific use case?
Right.
That's what we did with this.
It prints so fast, Padre.
I know. That's real time. People
Yeah,
don't realize that's not a time lapse. That's exactly what it's doing. Now we will make both of those templates. So the one for the Arduino holder and the one for the ultrasonic range sensor holder will be part of the show notes. So if you want to tinker with it, you just take that, download it, and then upload it to your Tinkercad.
Yeah.
There you go. All right, let's finish up because we're running out of time here.
Yeah.
We are really running out of time. We need to make the information coming out of our Arduino understandable to a very young old person who might be pulling into a garage.
Okay. So how would we do that?
Well, I went through a couple of different things. Originally I was going to put a screen that had like distance, but then I'm like, no, because my dad has trouble reading numbers without his glasses.
Yeah, if you can't see how far away the wall is, that might not. You'd have to have like a really big screen.
Yeah, not so great, not so great. So instead, I thought, hey, how about lights? We all know lights. Lights, you can make them as bright or as big as you want them.
Right.
And we all know that there's kind of there's a hierarchy to what lights mean. Blue is kind of okay. Green is good.
Right.
Yellow, orange means start to slow down, and red is like no.
Right.
Dude,
Just
seriously.
probably shouldn't use green. Well, I mean, I guess you could, but green means go, so he might just stomp on it.
Well, he's probably going to do that anyway. So what we're going to do is we're going to interface a WS2812 pixel stick. Again, that's one of these things, with our Arduino. So that we can get a visual feedback of what those numbers actually mean. So he doesn't have to know the numbers at all. He just has to know when he starts getting closer, it's going to get closer and closer to red. And when it's red, it means stop. So let's do the wiring.
Okay.
There we go. Go ahead and go to the overhead, Alex. All right. So we need to get 5-volt power to our pixel stick. And again, I've got red and I've got black. So I'm going to put ground there. And I'm actually taking the voltage off the voltage in connector. Right here. That's normally where I would put voltage into the Arduino, but because I've got voltage coming in through the USB, I'm actually going to take voltage out.
Cool.
Right, so I'm going to take 5 volts.
And then you have to do
I need a digital pin.
Yeah.
Right, so I'm going to put it on digital pin 7. All right, so it's not doing anything yet because I don't have the logic programmed for it.
Right.
But that's what we're going to do now. So if you go back to my screen, we've still got the ranging function running. So this is running our ultrasonic sensor. We no longer need that. I'm going to shut it down. Let's go ahead and add what we need to get the function working with the light. So what we have to do is we have to, hold on one second, we have to add a library. It's the same library that we used last time, the Fast LED library. That's the one that allowed us to do all the Christmas light stuff, right?
Yes.
So I'm going to put include, changes color again, and in quotes, fastled.h. Now I have access to all of the functions that were inside that Fast LED library. And I did it the exact same way I did the ultrasonic. I just copied over that folder into my libraries folder in my Arduino folder, and I'm good to go. Now I need to do the things that I did at the beginning of the Christmas light project. I have to define the number of LEDs. So pound define, it's going to change colors. and num LEDs. And how many are there?
7?
Oh,
8?
8.
Yeah,
so I'm going to tell it 8. So now I've got 8 LEDs. If I wanted to change this, let's say I wanted to use a big array. Let's say I wanted to use the Christmas lights. I could put 50, but I just have to tell it how many lights are in the string because it knows how many to work with.
Okay.
All right. Now I need to I need to tell it what data pin I'm going to be using it. In this case, define.
Which was 7?
Exactly.
That's
so data pin 7. So it knows that it can, actually I don't have to do that. It knows that I have access to the string by pushing out the data pin 7.
Okay. Do you not have to close those with a semicolon?
You don't, because
they're
includes.
functions?
Yeah, they're includes. All right, now I need to create an array that will be big enough to push out to all of these lights. Remember, we talked about how this works.
Right.
It creates an array, it fills the array, and then it pushes the array out through the data pin.
Right.
And then each light takes 3 bytes off the top of the stack and then passes on the rest. So I need to create an array that's big enough for 8 lights.
Okay.
Which is actually 24 bytes.
Makes sense.
Okay, so I'm going to go ahead and do it right. Here's my cursor. There you are. I'm going to do it underneath the initialization for the ultrasonic sensor, CRGB, which is that's an array from the fast LED library.
Okay.
LEDs, and I'm going to make it. Now I have to tell how big to make it. I'm going to say num LEDs. And close it off. So what I just did was I told it to make an array called LEDs, LEDs. That's the size that I specified up here.
Right, which is 8.
Which is 8. So now I've got that initialized. I need to add something to my setup. And again, this was from the same thing that we did in the Christmas lights episode. Fast LED, add LEDs, NeoPixel, and I'm telling it what kind of device it's going to be accessing. Data pin. Close it off. LEDs, num, LEDs. And don't worry about this because, again, you're going to have this code in the show notes, and I actually fully commented it in the show notes.
Ah, okay.
So it'll tell you exactly what it's doing.
Cool.
But essentially, this is initializing it. It's saying I've got a string of NeoPixels. It's telling it I'm on data pin 7. It's telling it that I'm going to be using the array called LEDs, and it's telling me how many LEDs I have.
Cool.
Okay, all right. So that's my setup. Let's go ahead and add in, I'm going to put this underneath my range debug and paste. And let me guide you through it, show you exactly what's happening here. So I've created a new function. It's called range LED, and it's receiving a variable called range value. Yeah, we'll explain what that means in just a bit. The first thing I'm going to do is I'm going to take the value light map. I'm going to create one called light map. I'm going to map the range value from 0 to 100. If you can zoom in on that. Let me explain what that means. This is important.
Right.
I am getting a value between 2 and like 3,000 off of my ultrasonic sensor, right?
And we saw that 3,000 was when it wasn't getting a signal at all.
Precisely. I don't want that craziness to happen in my lighting array. I wanted to make it a bit more predictable. So in this case, what I'm saying is from 0 to 100, so instead of 2 to 3,000, from 0 to 100, make it between the number of LEDs and 0.
Okay.
So in other words, if it's 0, meaning that I've hit it.
Yeah, that means it's not getting any signal.
Right. Then light up all the LEDs. That's what num LEDs means. Light them all up. If it's at 100, so if I'm at 100 centimeters or further away,
light up none of them.
Light up none of them. That's what that means.
Got it.
Okay, don't be confused by anything else. That's all I'm doing is I'm mapping values. I'm saying I can now handle values between 0 and 100, and if I am 0 centimeters away, light them all up.
Right.
And if I am 100 centimeters, have everything off.
And so if you're at a value of 50, it should light up half of them.
Correct. Now I want to do something a little bit different. Fast LED clear, all it does is it clears out the previous values. That's a necessary part. This is a little bit of programming that I created to make it a little easier because I don't want them all to be the same color. I want warning values for my dad. And so what I did was I said, okay, for 0 all the way up to as many LEDs I have. If a quarter, that's what 0.25, if a quarter of the LEDs light up, make them blue.
Okay.
The next quarter of LEDs, make them green. The next quarter of LEDs make them yellow, and the final quarter of LEDs make them red. Now this, I like this because what I could have done is I could say, if it's from 0 to 2, make it blue. If it's from 3 to 4, make it green, et cetera, et cetera. The problem with that is if I ever change the number of LEDs, I have to go back in, I have to change that.
Okay. Right? So this way you only ever have to go back to num_LEDs and change that value.
Because it's not doing direct numbers, it's doing fractions.
Right.
So if I have 100, if I use 100 LEDs, so I have a huge array because I really want my dad to see it, it knows the first 25 are going to be blue, the next 25 are going to be green, the next 25 are going to be yellow, and the next 25 are red.
Cool.
Yeah, so that's a nice way of sort of cheating. And then I set my brightness for 60. And the fast LED show, that's the command that actually sends it down the line. It says, go ahead and show this in the string.
Okay. Yeah, the final thing.
The final thing. And now I need to do one last thing. I need to change inside my loop. Here we go. So I've got, my debug is still on, but I have to call range LED. So I'm calling the function I just created.
Right.
And I'm passing it the range. So the number it just got from the ultrasonic sensor. Let's go ahead and check it, make sure I didn't make any mistakes. This is really easy, by the way. If anything shows up in red down below, I made a mistake. If it doesn't, if it shows up white, then I'm good. And come on, give me. You notice it's taking longer. Oh, good. It's taking longer because I'm using the fast LED library, because that's a big library. So now I'm going to push it up. So upload, and it's going to compile it again. And once it knows that it's right, it's going to go ahead and push it out to the Arduino, and I should start to see input as soon as it says done uploading.
Right. Oh, there we go, a little green bar.
Now it's uploading. Now it's uploading. It's using 22% of my program storage space. Now it's done uploading. All right, let's go ahead and go to the overhead, Alex. Let's get my dad driving the TIE Fighter. So as he gets closer, there we go, see? So I'm going to pull him away. So this is my dad entering the garage. With his TIE Fighter, and go overhead, Alex. There we go. And as he gets closer and closer, so now he's got blue, he's got red, he's got green, he's got yellow.
Dad, you're getting a little
Stay
close.
on target. Stay on target. Stay on target.
You turned off your computer.
Stay on target. Ah, Dad, no, stop.
Too close. Too close. Yeah. So that's what happens.
There you go. That's what happens.
That's cool.
Of course, he doesn't drive a TIE Fighter, but
no, he's more of a...
He's Filipino.
So he's more of a Star Destroyer guy, yeah.
This is a super simple, I mean, okay, we took a while to explain the code, but that's because we wanted you to understand it. This is a super simple circuit, and it's something that you can expand. Go ahead and use this. Use one of these rings.
Yeah. You just have to change the number of LEDs.
I've got much bigger rings here. This is my sort of stash of WS2812s. In fact, if you wanted to, I know there's a few out there who love our strands of LEDs.
Yes.
Well, this is a strand
one of them.
Of waterproof WS2812 LEDs. So I could like put this around the entire garage, so no matter where he is, he will see it.
Yeah. You could plug it into the sides and the front.
Well, think about it. I could wrap it around the ceiling of the garage, which means even if he's backing in, it doesn't matter if he's going forward or back.
Yeah.
The actual garage would start to light up the color that he needs to stop.
You could probably incorporate some sort of like a speaker or something into it, so it starts making a noise as you like get close.
I could rumble. That's the thing. Once we have the data inside of the Arduino, and we're happy with the results we're getting as far as accuracy is concerned. Any device you can plug into an Arduino, you can trigger it. Right. This is just logic.
So would you also program in like a turn-off switch or something? Like, because if he just pulled in and then parked the car and you didn't have like a function for like saying after this amount of time turn off, would just stay on the whole time?
And actually that's a very good idea. So what I would probably do is I would put an RTC, a real-time clock, and I would say if you don't detect any movement for 60 seconds.
Yeah, then just
turn off the light. Stay on, but turn off the light. And the minute you detect motion again, go ahead and turn them back on.
Yeah, I like that idea.
Yeah,
cool.
And this is how you develop. So you create something and you go, oh, it would be cool if I could do that. Oh, that's cool, but I wish I could do this. And eventually you get to something that you're proud of.
Well, and then I guess you could also program in something that if it does go red, like it does all the LEDs, it emails you like a picture from a webcam, and it's like, Yep, Dad hit the
Dad,
cabinets
you have
again.
crashed.
Yeah.
So next, it's like the entire wall turns red, starts flashing.
Right.
Like, no, seriously, stop the car. Stop.
Please stop. Please stop.
All right, folks. Before we go, we do want to thank the second sponsor of this episode of Know How, and you know, it's one of my favorites.
DigitalOcean.
DigitalOcean. There were a lot of booths at CES, and they all have to have some sort of internet presence. I mean, let's face it. In this day and age, if you don't have a presence, if you don't have a service, if you don't have a good website, if you don't have an app, well, you kind of don't exist. And that's what DigitalOcean understands, because they make their service developer friendly. Do you want to test your service for just a couple of minutes with a limited number of people in one region of the country? You can do that. Do you want to expand it quickly so that you can push out to an entire state? You can do that. Are you ready to go global, expanding your service, your app, your website everywhere, geolocated around the world? You can do that all with a couple of flicks of a slider, because that's what DigitalOcean does. It allows you to take your app, your service, whatever it may be, and to encapsulate it inside of a container, what they call a droplet. And then you can run that droplet up on their hardware. Now, imagine this. It's used by over 600,000 developers, including me, including Twit's Randall Schwartz, Aaron Newcomb. It's one of these things that it's sort of become second nature. It is the best way to get up and running. You can deploy and configure your droplets via a streamlined control panel, or you could use their API, and you get to choose your OS. Ubuntu, CentOS, Debian, Fedora, CoreOS, FreeBSD. You choose the flavor, and they'll take care of the rest. You could also select from one of the many pre-configured one-click builds. You could get Drupal, Docker, Node.js up and running, and you can build exactly the infrastructure that you want with root access to servers running 100% SSDs in state-of-the-art data centers across the world. Oh, it's highly scalable to meet the demands of a rapidly growing application or business. Like I said, start small and then grow it when you're confident that your infrastructure can handle it. They've also got an extremely active community. This is one of the things that I look for when I'm looking for a service. Are the people who are using the service happy? Are they happy enough to share their knowledge with others? And the answer to that is yes, yes, and yes. If you use DigitalOcean, you'll become part of an ever-growing community of people who understand that this has saved them so much time and frustration. It's so easy to get started that you can deploy your own SSD cloud server in as little as 55 seconds. Now, here's what we want you to do. We want you to try DigitalOcean. DigitalOcean has incredibly affordable and straightforward pricing, with servers starting at just $5 a month. There's also hourly pricing available starting at less than a penny per hour. But you know what? We're going to make it a no-brainer, easy for you to get started today. Visit DigitalOcean.com and create an account. Once you confirm your email and your account information, go to the billing section and enter the promo code KNOWHOW, and they'll give you a free $10 credit. That's plenty to get started and explore what DigitalOcean can do for you. That's DigitalOcean.com, DigitalOcean.com, and once you sign up, enter the code KNOWHOW, KNOWHOW, in the billing section and get your free $10 credit. And by the way, congratulations to DigitalOcean, who just launched their 10 millionth droplet. And we thank DigitalOcean for their support of Know How. Hey, Brian.
What's up?
That was a lot.
That was a lot. Yeah, at least, you know, it was a lot, but my face doesn't feel like it's melting off.
It's not melting off, and we didn't talk about quadcopters.
No. We only said it like 3 or 4 times, so.
We will, though. We will.
Yeah.
Now, on Monday, we're actually going to be doing, you're going to be showing us Magic Lantern on your DSLR. It's been getting a lot of buzz. It's a nice way to get a bit of more functionality out of your camera.
Well, yeah, it's like I have a T3i, and it's a few years old, and there's a lot of features that Canon just didn't bother releasing with the software that you can take advantage using Magic Lantern that are really helpful if you use it a lot for video, like we do here for our projects and things like that.
Yeah, I love it. Folks, that's all the time we have for this episode of Know How. Don't forget to join us again on Monday. We're twice a week now, and as long as you're joining us, you know what you should do? You should probably check out our show notes. Brian, where do they find those?
They can find those at twit.tv/KH. And not only can you find our show notes, but you can find any links of things that we talked about and previous episodes if you happen to want to download them, which would probably be really handy, especially for like Arduino stuff where you're going to want to go back and watch some of the stuff.
Exactly. Yeah, and don't forget, you need to download the code examples. We give it to you, so you don't have to guess. You'll have exactly what we used, and actually it's all commented, so it's even better than what we used on the show. And you'll also have the files, the STL files for those 3D objects. So if you wanted to create your own Arduino ranging holder thing for whatever application, you could use the same files that we did.
No, that's not the only place, Padre.
No, we're on the Plus.
That's right, the Google Plus group. And that's where you can post either questions to ask all the other know-it-alls, or post project pictures, or, well, you can post your crash videos too if you're flying drones. Those are always fun to watch.
Yeah, please give us videos. We love to hear your stories. In fact, we're going to be showing off some on Monday. We like the projects that you do. We want to make sure that you get props for sharing with the rest of the know-it-alls. That's also not the only place that they can find us on the socials.
There's another one.
Yeah.
If you want a behind-the-scenes look at what we're doing when we're not doing know-how, that would be Twitter. And I am at Crinky_Hippo.
And I am at Padre SJ.
And we have one more person that works on the show.
We do. We have a trio.
No, we don't. Let's wrap.
Oh, wow. Well, the person who doesn't want to be known is Alex Grumple, and you'll find him at ANELF3.
I was
Excuse me,
hoping
Padre. That's Gumple.
Oh, I'm sorry. Oh, I always get that wrong.
I was hoping he was going to show the way that I wanted to clean the studio between the three of us.
Well,
but we'll have to save that. Go on Twitter and find out.
Only there's a link in the rundown.
Until next time, I'm Father Robert Ballecer.
And I'm Bryan Burnett.
And now that you know how.
Go do it.